Hey everybody, in this video we are going to do what you see on the screen right now. We're going to calculate the value of each of the following trig functions or evaluate trig expressions of special angles, and I'm not going to bring a lesson. This is more so an answer key with a quick little chat. Anything that you want lesson wise, you have to go find my playlist that corresponds to any of these topics, okay? So I have cosine of 11 pi over 6. 11 pi over 6 is going to terminate right about there. Cosine is the x value over a lot. That means the answer is radical 3 over 2. Sorry about hitting the camera. Tan of 5 pi over 4. 5 pi over 4 is going to terminate exactly in the middle of that quadrant. Tangent is positive in that quadrant. Any angle over 4, the tangent of is positive 1. If it were in the middle of one of these, negative 1. 5 pi over 2. Well, this is 4 pi over 2, so 5 pi over 2 is over here, coterminal with pi over 2. The tan on the sides is 0. Tan on top and bottom is undefined. Tan again, 2 pi. Like I just said, tan on the side is equal to 0. Sine of a negative 11 pi over 4, that means I go all the way around, and I am terminating right here in the middle of quadrant 1. Over medium, up medium. Sine is my up. I'm going up medium, root 2 over 2. 16 pi over 3. Pi over 3 will be tall and skinny like a tree. That's 2 pi, so it's 6 pi over 3. Another loop gets me 12 pi over 3. Another loop will be too much. It's 18 pi over 3. So I'm going to count from 12, right? Yeah. 13, 14, 15, 16. 16 pi over 3 gets me right here. The cosine is the x value. Left a little, down a lot. The left a little means negative 1 over 2. Negative 1/2. Cosecant is the reciprocal of sine. Negative pi over 2. Negative pi over 2 gets me down over there. Sine over there is negative 1. The reciprocal of negative 1 is still negative 1. 7 pi over 6 will terminate right over here. Secant is the reciprocal of cosine. Secant will be then, if cosine is negative root 3 over 2, then secant is negative 2 root 3 over 3 because, well, we memorized our reciprocals because we are responsible young students, right? 4 pi over 3, tall and skinny like a tree. So that's 3 pi over 3. 4 pi over 3 is there. To keep checking, 5, 6 pi over 3 is 2 pi. It makes sense. 4 pi over 3 is there. Sine is the y value. Over a little, down a lot. Tall and skinny like a tree. So that means sine is negative root 3 over 2. Next, cotangent is reciprocal of tangent. Negative 9 pi over 4. If I go this way, that's negative 8 pi over 4. Negative 9 pi over 4 is going to terminate right there, exactly in the middle of quadrant 4. Anytime you're in the middle, tan is equal to 1 or negative 1, in this case negative 1, and cotangents are reciprocal, so it's actually still negative 1. Cotangent of negative 5 pi over 3. Negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, tall and skinny like a tree. It's over here. Cotangent. The tan of anything over 3 is root 3. That means the cotangent of anything over 3 is root 3 over 3. We're in quadrant 1, so it's positive. Cosine of negative 2 pi over 3. Negative 1, negative 2 pi over 3 is here. Tall and skinny like a tree, over a little, down a lot. Cosine is your x value, over a little, so left a little, negative 1/2. Secant, reciprocal of cosine again, of negative 7 pi. All of the odd pi's land here, I can promise you that. All of the even pi's will land here. Secant goes with the x value. Negative 1 is the x value. The reciprocal of negative 1 is negative 1. Done. Cosine of negative 7 pi over 4. Negative 8 pi over 4 is all the way. Negative 7 pi over 4 got me right here in the middle of quadrant 1. Over medium, up medium. So that means, so it's similar to E up there. So that means the over medium is over root 2 over 2. That says root 2 over 2. And the last one in this batch, cotangent of 3 pi over 2. So that means right here, tangent is undefined on top and bottom. That means cotangent, which is the reciprocal, will be 0 because 0 is the reciprocal we use for undefined. So that's the end of this little section here. Hopefully you got them all right because you're so smart and beautiful and wonderful. So thumbs up if you're doing great, thumbs bad if you're doing down. You know what I'm trying to say. Playlist is in the screen at the end here. I'm going to the next section now, which is going to be evaluating these. I'm going to more or less be doing the exact same thing. I'm going to add or subtract the angles on the inside. You don't need to do angle sum or difference identity unless one of the angles on the inside has a 4 on the bottom and the other has a 6 or a 3. Well, in that case, where you're finding these sums and differences, okay? In that case, you would have to do sum or difference identity, but because they have 3s and 6s on bottom, I mean, if we add or subtract them, we're going to get something on the unit circle, so these examples are kind of silly. I didn't make them. Don't be mad at me. But maybe you are happy because they're easier. And I'm done blabbing. Bye for now.